Hi and welcome back to Properties and Structure of Matter, Inquiry Question 4 on bonding. We've already touched really on these intramolecular bonds, but I just wanted to tie it all together now that you've seen the other type of bonding. So we are looking here at some of the things that we already know. So some of those things we already know: atoms of our covalent bonds share our electrons. Most of our covalent substances we have, water, carbon dioxide, exist as molecules. Now, the big thing here is these atoms within these molecules are held together by really strong covalent bonds, and these are our intramolecular forces. So let's have another look here. We've got our covalent bonds. Our covalent bonds, we have two different types, our polar and our non-polar. So our non-polar is when there's that even sharing of our electrons. So again, here you can see where our electronegativity is the same, then the difference in the electronegativity is 0, so there is an even sharing of those electrons there, and these bonds are really strong bonds. So again, they're going to have higher melting points and boiling points. So the alternative we have are our polar bonds. So again, when the pull is not identical, so the atoms that are joining together aren't identical, they're going to have different electronegativities, and so the pull of electrons will not be evenly shared. And if we have this unequal sharing of the electrons, we'll get a polar covalent bond. And there we see that we have a partial positive charge on our hydrogen and a partial negative charge on our chlorine. That was covered in previous videos, so go back and refresh those if you need to. Just out of interest, some interesting points here with some energies that's required to break these bonds. If we're looking at our dispersion forces, and we've talked about them being our weaker ones already, we've got a dispersion forces energy required to break them of about 0.05 to 2. So you can see really quite small. Our dipole are stronger again, between 1 and 10 kilojoules per mole. Hydrogen stronger again, between 20 and 40, but you can really see the difference there between the covalent and the ionic bonds. So you can see here these are our intermolecular, so between the two different bonds, and here we've got our intramolecular, so in between, and then we have our ionic bonding. And so you can really see there the difference in energy required to break them, and then this relates to their physical properties and that we've discussed before. Again, just a little flowchart having a look at pulling all of these things together. So you can read through this yourself, but for example, interacting molecules or ions, are ions involved? Yes or no? Yes, okay. Polar molecules and ions present. So does it become ionic bonding? Is it ion dipole? Are we looking over here more in our covalent type bonds? Are polars involved? Dispersion only? Do we have hydrogen bonding? Yes. Then we've got the hydrogen bonding here. Are polar molecules involved? Yes. Have we got hydrogen bonding involved? No. We've just got our dipole. And that's a really good summary then of all of our forces that we have. Okay, so this should tie things up. And we'll talk about things a little bit later to make sure that we have that understanding. See you soon for the next video.